Someone do that, please. um, so I don't lose the file. So welcome to our service learning project. We are today working with Spring Woods High School in the Spring Branch ISD district. We are Scholars Academy, and we are bringing presentation of a town hall kind of meeting of what is data science and what is UHD, what is Scholars Academy, and we're here to help the students learn more about the opportunities they have here and about STEM in general. So let me start off with introduction of what is Scholars Academy. So Scholars Academy is a scholarship group that is here at University of Houston downtown that provides students with opportunities for research and improvements to their skills of what they need to graduate, get a job, or do further things such as research or getting a PhD in the future. So if someone else wants to talk.
The question is, what is Scholars Academy, right?
Yes. If you can, do you have anything else to add?
Well, Scholars Academy for me, it's like it's a connection for students who are also trying to find people who are motivated to like learn. Like, so we have the PLTL and CLCC, which are places for students to come together and collaboratively help learn or study together on certain subjects that they might find hard. And I thought that was like a really nice way to like have students interact and like make connections with each other.
So you guys already defined what Scholars Academy. I want to talk about how Scholars Academy feels like. It feels like a group of very competitive people. You get to see your peers succeed, so you feel driven to succeed also. It's like a group of people who share resources, opportunities, and we all work together to finish UHD strong. And for me, because I'm an international student, also it meant that I was able to continue my education because through the scholarship, because the most you contribute, the more scholarship you get, kind of thing. For example, if you tutor and you do community service and etc., they give you benefits, and that helped me graduate. So I think Scholars Academy, it's kind of a great community to grow into and out of it. Yeah.
That really does answer the question. Second question, how has SA benefited you? And Oda really covered that well there. Is there anyone else that wants to have anything else to add to that?
Yeah, I think, can you guys hear me?
Yes.
Yeah.
You know, I think SA for me, like one of the things that I never knew about was like, I never knew about like, you know, like graduate school and like, you know, I kind of had an idea of what I wanted to do in college, but I didn't know what I wanted to do after that. And so I think Scholars Academy for me kind of opened my eyes to the possibilities like after graduation and kind of what it takes to kind of be like professional and not just a student anymore, you know, which is something I still have to kind of deal with. So, you know, it helped me a lot kind of learn about what I wanted to do, especially after graduating with my bachelor's degree.
I want to add something to the question as well. So SA to me is more like a family. And then, you know, like whenever I felt left behind, there's always someone, you know, like motivate me to keep moving forward. And also I think that a lot of students are gonna have the same feeling as me when we were like freshmen or sophomore, that we have no purpose. So SA actually give us a purpose, like a goal to keep going, either to go towards our academic career or to go to the industry for jobs. So they prepare us, you know, like for resume, CV, and a lot of things that we could potentially find a job or, you know, keep moving to master's degree or PhD.
I wanted to say something. I know everyone has said amazing things, but For me, when I think of SA, the first thing I think of is like you have a goal, which is, for example, if you go to the gym, you have a goal and your goal is to lose weight, but you just go there and you really don't know what to do. And you're just kind of looking around like, okay, I'm just going to copy what everybody else is doing. So like SA to me is like having a personal trainer, like someone guide you on the way and say, okay, do 20 squats or do this and do that. And they help you grow and they see your progress. So SA has definitely done that for me because I've been able to stay on track on my path throughout college. And I'm not just like wandering around like until graduation. And I'm like, oh, so overwhelmed because I've never applied to an internship, never applied to, don't know anything about job applications. So these are the things that they prepare you for before you actually get out to the field. So I really love the fact that they help you academically and also mentally to be prepared for the real world.
So I think that covers a lot about SA, but I think I want to move on to what Mr. Angel is a teacher of. And Mr. Angel is a computer science teacher at Spring Woods. And what I want to cover today for his students is to cover a bit of data science and what we learn here at UHD. And we want to show them a different side of computer science that is based off of math and is very interesting to for them to think about if they want to do STEM and computer science in the future. So the first question of this is, what is, for a student that doesn't know what data science is, does anyone want to give them a brief background of what a data scientist is and what they do in general?
I could try to give this a shot. Data science really is kind of the combination of computer science, statistics, and mathematics. I think it's a beautiful new emerging field that is like a new way to process all the vast amounts of data that we have that exist kind of now with all of the technology in our modern day. And so coming into this, you really are pushed to use the tools that computer scientists are using, but statisticians don't quite fully understand. And so it's a combination of trying to maximize and optimize the use of these tools. So it's really interesting to see how people that have more of a computer science heavy interest, how they participate in data science, and how people that are mathematicians, statisticians want to participate in data science as well. And so it really allows you to look and explore into cleaning, processing, and analyze any of the types of data that you're really interested in.
I would even say for me, like, one of the things when I think about like data science, I think about like, one of the, I mean, it's kind of in a very like broad term, and it can be kind of like, kind of like this kind of buzzword that everybody's using. But I think for me, like the thing that I think about when I think about data science is like that we're trying to like, we're most of the time just trying to find patterns. So it's like a lot of times you'll have like huge, basically, files of data or the basics of it, which is basically just information. So you've got all this information, you don't know what to do with it. And so you're trying to find patterns that help you, predict, analyze, do that kind of thing, whether that's like in biology, whether that's in like finance and economics, whether that's in business. I mean, there's all different kinds of things, right, that data science is used for. And so, I like the idea that, we're kind of like taking like mathematical, like there's like these different like math concepts that we're basically using computers to compute for us to find patterns and that kind of thing.
I want to add to that. Because data science is basically analysis of data, it can be applied in any industry. So you can see different backgrounds for data scientists, maybe an economist data scientist, a computer scientist data scientist, maybe in health. For example, people are building tools to predict how much calories you can eat. So if you have diabetes type of thing, you can use computer science and data science to achieve that. So if you're thinking about, hey, I don't think I have the background of a data scientist, you probably do, because we come from every background. It's just that after we just learn the tools necessary to apply data science to whatever field we want to go into.
So I think that really goes into the next question of like what is the curriculum at UHD at as a data scientist. So data science here is actually kind of a new program. It's been out there for roughly 3 to 4 years through the process of approving through the UH system and letting us accept people in our majors. And so most of us are seniors here, and we're graduating either in a few weeks or next semester. And so we've been through a lot of the data science classes. They each go through different subjects, and they cover different curriculum that we must need in the field, such as working with Linux and working with Python or R, and most of the curriculum is based around statistics. And so it might be a lot for many of you guys out there that don't know statistics yet, but UHD curriculum really goes through it really well with the teachers that we have. We cover everything with the students, what they need to go out there in the field or do graduate school in the future. I was gonna ask, is there a sort of underclassmen out there that wants to tell their experience of what data science is so far compared to a senior's perspective?
I'm a sophomore inside data science, and I'm not gonna lie, the math can be a little tricky, but you could. But at UHD, a lot of the teachers are really open about students asking us questions. So if you ever have any questions, or if you ever get stumped on something inside UHD, just like ask your teacher during like a private session or something. Or you could even like go to like PLTL or CLCC, like I said, that Scholars Academy does have and host, where students do come together and they try to collaborate and help each other out.
I think for me, the hardest part was me choosing the domain part, because you have the focus, which is data science, and then you have to choose a domain. That means like you have to take 4 classes in an industry that you're interested in. You could choose to take 4 classes in computer science or 4 classes in finance or something else. That decision was the hardest for me. But the rest, the classes are built up of each other. So whatever you learn on the first semester, you're going to be prepared to tackle the second semester and so on. And you're going to see that the professors are open and available. So you can ask questions, meet with them during office hours. They can explain further into. And I guess particularly for UHD, the data science community is small. So basically all data science students know each other. So therefore we also help each other in a friendly manner without like intimidation type of thing.
So the next questions the students had was, what does it take to be a good data scientist? I know the question seems kind of broad for most of us, but some of us have an idea of what to do.
I think you have to be able to, I think like the most important thing that you have to do to be a good data scientist is you have to be able to really critically think. Because like, you know, you may not always, like you're basically given these problems, but you don't even know like what maybe even the problem is sometimes. So, you know, depending on the project, you may say, okay, I have all this data, but like, what am I even looking for? Like, what am I even trying to do? And so, you know, I think a lot of times you have to think about, okay, like, you know, what are the kind of things that would be interesting to know out of this information? What are the kind of things that I would want to know? What are the kind of things that I would want to like use if I were a business, if it were just me or whatever. And so like, you know, I think the ability to like critically think and be able to take all the different, because since it is so broad, like I know like our classes, they're not just all one, you know, they're not all just taking math classes, they're not all just taking computer science classes or all just taking statistics. There's all these different fields that like you're kind of having to bring together. And so you've got to be able to like really think and be able to like solve problems well and say, oh yeah, well, you know, I learned this in this class and I could use that here to do that. And like there's not, you know, because there's not like an easy answer for a lot of these things. So I think, you know, being able to critically think is probably the most important thing about being a data scientist.
Another thing about data science is like it's really similar to computer science. So like whenever it comes to coding, you need a lot of perseverance and you need a lot of determination. Because if you get stumped, like say some part of your code's not working, you got to find out what it is. Like you got to just stick with it, you know. Just tough it out. Try to see where the error is, and it doesn't hurt to also work collaboratively, because whenever you work with a large data set and you're trying to do it as efficiently as you can, somebody else might have like a better idea. So it's better to like kind of work off other people and like of course try to put them in the work, just like give them credit and everything.
Definitely. Just to add to what Marcus said, you're gonna have to use a lot of debugging skills because most of the tools built, the libraries, Python and whatever, you're gonna have to kind of inherit classes and mix functions together, and you're gonna find bugs. And I guess that's where the computer science kind of mentality kicks in. You realize that besides being a data scientist, you have to be a computer scientist. I would say that.
And one thing that goes along with bugs and all that, in here, I would say the internet is always your friend. Whenever you have a certain question about how do I pull a row or how do I pull a column, someone else has probably asked that on the internet somewhere, and all you have to do is slightly look it up, and it's probably the first link. So I always, if I don't know something, I always turn to Google, and it's always my friend. I'll find it in the first 2 links of what I want to do. And it's very helpful for me to get things done really quickly and really fast as learning data science. So the next question is,
interject with one
Mm.
sort of like added question to that, because we're coding in Python in this class in particular. This is my computer science 1 class. And so they're going through all these exercises, they're experiencing, you know, coming across problems that they get stuck on, they get error messages. And one of the things they try to work on is reading the error messages and knowing, like trying to figure out what the error is. So maybe if a couple of you could tell me like what could explain to me, like what is your, I know you mentioned Google, like what is your like go-to method for solving bugs and understanding error messages? Do y'all have anything that you know works that you always kind of do over and over again, you find yourself doing?
I kind of have 2 different ways that I do. I basically like a lot of times if you take the error and like if you just, I mean, it sounds like, oh, you know, I just talked about critically thinking and like thinking hard, but if you literally just like Google, you know, type in your error, like you just copy and paste your error straight into Google, usually you'll have someone that asks the exact same question with almost the exact same scenario, usually on like Slack or something, or, you know, and they or you know, a message board somewhere, and then they'll have somebody else that have answered it. And it's like, oh, well, that's, you know, and you read it and you go, oh, I did that. And then sometimes like if that's not enough, or if that's not, you know, you can't really find your answer doing that, a lot of times what I will do, and what I like, especially about Python, you know, which is why I like Python a lot, is that like for every, you know, every package, every function that you use, everything in Python, it has documentation online. So if you know, okay, you know, I'm using the pandas, you know, I'm using that package. Okay, so I can just look up on Google pandas documentation, and I can go to, and basically the documentation basically is just where the people who made these functions, what they do is they will write down, okay, this is how you use it. Like, this is what goes into it. This is exactly what you need to do with it. Like, this is what you can and cannot do with it. And then it'll also tell you, it'll also give you examples of how to use it. And so what I like about that is that like a lot of times I can go and say, oh, you know, I didn't realize I was doing that, or, oh, you know, and usually just having to gain more information is something that always helps with me.
Okay.
You can go ahead. It's okay.
I was gonna say something that helps me is I know it sounds a bit silly, but Python is very tricky and it can give you an error for like the tiniest thing and it gets you frustrated sometimes. So you have to be definitely detail oriented and make sure that you're looking at every line of code because sometimes it gives you an error, let's say on line 27, but the mistake you made was on line 25, but it's affecting 27. So sometimes instead of having just a chunk with all the codes in one block of code, I kind of break it into different lines so I run one line at a time or 5 lines at the time to see, okay, is this line working? And then if it runs, then I keep running and see what line gets the error. And most times you normally catch it through that. So that process is kind of slow if you have like if your code is pretty long or lengthy, but it works for like shorter amount of code. So that's something that helps me.
I mean, 80% of your bugs and the things that like when you get errors on your code is going to be like dumb stuff like, oh, I just left out a, it's like, oh, I have this big like equation. It's got like 3 sets of parentheses. Oh, and I forgot 1 parenthesis on this side. And so then it's reading. It's like sometimes you're just like I'll do that and I'm just like, I'm an idiot, and then I'll fix it and then keep going. I mean, that's literally most of our errors that we have. And so yeah.
The other thing we have to look out for is the data input. So when I get errors, besides doing most of what my classmates said, I have to make sure that whatever I put in is exactly what should be the input of the program. And always check for the output, because sometimes you pass the data or the code through a pipeline and then you get something out of ordinary, and that's the error, but you can't see it because you actually just conceptualize that that's what your code is going to do. But then you realize, oh, so the error is that actually my code is returning an empty list. It should have values, type of thing. So always check for inputs and outputs.
Yeah.
Thank you all for sharing that. Appreciate it.
So the next question that we have is, what part of majoring data science interests you? And for me, I'm going to answer this one, but I think it's the adaptability to any field you want. You can go into a tech company, you can go into a finance company, you can go out into the medical field, you can apply it anywhere you would like. I know there's a question that I saw on that the student submitted. One of the questions was the auto industry. How do I adapt data science to the auto industry? And one thing that comes to mind is self-driving cars. And self-driving cars is using computer vision and using machine learning to kind of detect what are cars, what are humans, what is the road, what are signs. And so that's part of building models and building algorithms into helping make a self-driving car happen. And we can see that in a Tesla, for instance. We see that it's a self-driving car, it's well known, and it works really well. And so that's that they went through the process of training and building models over the years to achieve what they have now.
I think one part of majoring in data science interested me just that I not only can do the thing that I'm following to my career, which is to become like a data scientist, but also can do something like as my hobby in order like to make money. So if you have a dream, you're definitely gonna need money like to build that one up, right? So learning data science helped me analyzing stock market, which is what I'm trying to do with trading options, like as an undergrad student. And it's pretty fun that I can learn, I can read chart, I can make money off. And also, this is my side hobby too. In order, for me to, have me pay off on my bills and my tuitions and so on. So majoring in data science literally, as Brian said, that you can, do, it's doable in multiple fields, and it's gonna help you, like grow yourself, financially, and also, like become knowledgeable.
I think it's important. The way I see data science is that you get to be an explorer. So you have these tools and now you get to find knowledge in places that maybe people didn't think about it. For example, I was searching for a job and I was like, this is too many job applications to read through. So let me build a model and select all the text and see what words pop up the most so that I can focus on that. For example, I wouldn't think about doing that if I hadn't majored in data science. It's something that could make my life better. So it's kind of the aspect of being an explorer and a technologist that interests me the most.
And I think that I'm gonna do one more question before we try to do some demonstrations of applications of data science. And the last question is, how much do you have to study for data science and how many years?
Well, we have this amazing program, which is, your standard university 4-year program, and that allows you to get a major, a bachelor's degree major in data science. And I'd say you're pretty well prepared with that university degree. You're prepared to go out into a field, and that particular field will say, okay, well, we want to use these specialized tools, and you'll learn more through your career. As for how much do you have to study for like a daily basis for your certain classes, a lot of our work is project-based. So if you really like project-based work, it's a really exciting program to be a part of, because you'll either get a lab that's weekly, or you'll get a test that's kind of project and solution based that you prepare throughout the few days. It really depends on how you like to study or how you like to work. If you want to do it chunks, like 5-hour blocks or 6-hour blocks, sometimes I get really into coding and I just want to code for that long. Or if you like segmenting that work and only studying 2 hours a day, it really allows you to have that kind of flexibility. And I guess in addition to studying and in general being a part of a university program, I want to re-highlight the fact that Scholars Academy really pushes you to do research. And I think that is the most important thing when it comes to studying, because you're using the tools that you're learning in your degree in real world applications. And that's what, if you want to go to grad school, that's what they're looking for. If you want to end up going into a really intensive field after your bachelor's, that's what they're going to be looking for, is your research experience. And of course, your grades and how much time you commit. But it's a part of your studying process. And I think it's really exciting because all of your studying is hands-on. So yeah.
I would say to add. Oh, go ahead. Go ahead.
Oh, okay. I was just going to say, to add to that, definitely one way that I know that helps me is finding a group, a study group or a study partner. Some assignments, of course, you have to do them individually, but if you have a group of people or at least one friend that you can study with, and you learn a lot based on, if I'm making an error in my code, I can easily, my friend can point it out and say, oh, I did this differently. And I love the fact that with coding, you don't have to do it. There's not like one particular way to do it. There's several ways to get to the answer. So studying gets very easy doing it that way with like a group of people or just one person.
I would say, kind of just to add on to what you guys said, how much you have to study for data science, I would say it's just a lot. I mean, like, I think Marina said it was exactly right. Like, you kind of have to be very kind of self-driven, because again, a lot of this stuff is, which I like having projects. I like, having 1 or 2 big projects and being able to like use all the stuff and, split up my time and being in charge of my own time. I like that. But I definitely think it is a lot. I mean, I know that we've spent, even with a lot of these people, I think a lot of even us in this group, like, we've spent a lot of time together, like doing projects and working together and that kind of thing. And so, yeah, it's a lot, but it's fun and you learn a lot. So
I think that covers most of what the students really asked for and tried to understand what data science is. And what I want to do now is kind of demonstrate one type of thing that we learn. And I think this goes for the seniors, and I don't think the sophomores have learned this yet, but we have something called neural networks, which is a type of machine learning. And there's this fun website, and it's called Playground TensorFlow. And I believe I sent it out to all the students, and Mr. Andrew sent it out to everyone, that this is a fun little tool that you can start to understand what some of the things that a data scientist does. So I believe that Chad sent me this, so I don't know if he wants to talk about it a bit more in depth than I do.
Yeah, how much time do we have until this class is over? Just
We have 20. We have 20.
20 minutes. Do you mind if I pull it up on my screen and then screen
Yeah, you can screen share. I got it.
All right, can you guys see that?
Yep.
Yes, sir.
Yep.
Okay.
Yes, we can.
Alrighty, so this is kind of like one of the biggest things that is like one of the most kind of hot in the streets tools that data scientists are using right now. And basically it's called a neural network. So I don't know, I don't think many of you guys have taken a lot of calculus, so I will, I'm gonna try to keep it, just kind of interesting and brief. But basically what a neural network does is if you think about, kind of how your brain works, which is why you have the word neural network. You basically have a bunch of, you basically have your brain cells, they fire, and you have your dendrites and your axons and all that stuff, and like your actual brain cells, and they fire, and whenever one fires, it fires another one down the road, there's another one down the road, another one down the road, and obviously that's how your brain works, to store memories, to taking information, to move, all that kind of stuff. And so what neural networks do is it's basically just a math tool that we use to do things like classification. So if I'm trying to figure out how to classify the difference, if I'm a self-driving car, if I'm trying to be able to, if I have a bunch of images and I'm trying to classify, the difference between a stop sign and a person, like obviously that's important to know if you're a self-driving car. So you've got to be able to classify those things, right? And so what it does is on the left side, you throw in a bunch of basically numbers. So if it's a color, you'll give each color a number. If it's, an image, you'll give, each piece of the image a number. I mean, so you have numbers you put into the left. And basically what's cool about it is that it's pretty simple. So it's kind of just like it's just like a function. So you throw in these numbers and you can see that each of these lines is a weight. So you multiply those numbers by those weights, and it goes to this neuron, and it basically makes the number a little bit smaller, and transforms it a little bit, and then it multiplies that number times another weight. And you can do that as many times as you want. You can do different sizes of the different layers inside, and that's basically it. And so what's interesting about it is that because you have the weights, you can do really cool stuff like being able to classify, if I have a bunch of heights and weights, if I take heights and weights of random people, off the street, and I'm trying to classify whether or not that they're male or female, or, or where they came from, stuff like that, then, I'll take in a bunch of information on the left of them. And then what you do with a neural network is you train it. So you go through and you test it. So, if I take 100 samples of height and weight of people, maybe, as you can see, the ratio of training to test data over here is 50%. So let's say 50 of those people are my test data. So I'm trying to make sure that I classify those correctly. And then after that, what I'll do is I will try out, after I've trained it on those 50 values, I'm going to try it out on the other 50 values that I haven't even touched yet. And so, if your data maybe looks like this, and this is, the data that I know, right? So I'm trying to figure out, okay, what's the best way to classify this? And it takes iteration. So you have to go, it'll run through, it'll check and see if after it gives it random numbers, basically all these weights. And then at the end, if it doesn't classify it correctly, it'll update each of these weights, and basically uses the derivative in calculus. Okay. And so what you can do is you can train these things over several iterations or several generations. You can train them to learn how to classify images, learn how to classify all different kinds of different things. So, let's say I have even data like this, right? And I give it X1 and X2, and I have all this stuff. And what I can do is I can actually run it up here, and you can see, how it kind of works. And obviously like, okay, that one's pretty quick, but what if you have something kind of crazy, you have data that looks like this? Well, then how does that go? well, you kind of maybe want to add some more information, more features about it. So if I take height and weight, I may also take, hair color and levels of testosterone, that kind of stuff. I'm taking in more information so I can be a little more specific about how I classify things, right? And as you can see, like as it's moving, as it's running up here, you see, okay, I'm on the 45th. This is epoch, just means like iteration. So, as the iterations go down, you can see it gets more and more. It tries to get more and more accurate, but basically, I mean, and this one will take a little bit longer, but after the more time it runs, you can see we want this total loss to go down and down and down, because we want to be able to classify these data points correctly. And so as you can see, you're like, oh man, that's kind of crazy. It's actually moving, especially right here. You see it's kind of morphing to, that if I were to throw a random point like right here, it would classify it as orange. If I were to throw a random point right here and ask it what it would say that's a blue thing. So, it's like male, female, that kind of stuff. And what's interesting about neural networks is that they can be used in way, way, way more ways than you can think. So like, one of the ways that you guys probably see it in your lives is like if you have Netflix at all, well, what they do is they have neural networks and things that they try to figure out, okay, how can I, Netflix is thinking to themselves, okay, how can I get more people to stay on? Well, I'm going to get more people to stay on by recommending shows to them. So, they know, okay, if you're someone who, like me, you love The Office. I love The Office, my favorite show of all time. Okay, so they know, okay, people that watch The Office maybe also watch these other shows, and they watch, Parks and Rec, or they watch Community, or they watch, and so it'll recommend those shows, which is why you'll see whenever you get on your Netflix account that whenever you whenever you scroll down, it'll say, okay, excuse me, it'll say like, okay, here are more witty sitcoms, or here are more, and it'll recommend Friends to me usually. It'll recommend stuff like that. Or if I'm watching shows like The Crown or Last Kingdom, it'll say, okay, here's more, historical drama TV shows, and it'll recommend those to me. And basically it's a way that they've learned, okay, because Netflix has millions of subscribers. So if you imagine if you've got, millions of different inputs you can put into this, and you can say, okay, I can do things that are slow burning, that are drama, that are history, and each show and each movie is given kind of like a tag, and it's given a lot of different features. It's a movie, it's a TV show, it's this, I mean, it's for kids, it's for older people, and there's all different kinds of elements that they attach to every single show or thing that they've got on Netflix. And so they use those features to try to figure out, okay, what can we recommend to them that they're actually going to watch, right? And we all do that. Like we all use that. Like that's exactly most of our shows we find. I mean, how often do we just scroll through and go, oh man, that looks good, and oh, I'll click on that, and then we're like, oh, that's the best, that's a great show. How come I've never seen that, right? And that's because they use this kind of stuff to specifically recommend to you better shows, better movies that are kind of like things that you've watched before, but that they're pretty sure you're going to like if you watch it. And so, I mean, they do the same thing with Spotify. Spotify does a very similar thing. You can use neural networks in things like driverless cars. So understanding, like I was talking about, a driverless car just has cameras, and it has sonar sensors, and it has all different kinds of stuff that's taking in all this information. And so, Tesla, for example, they have to train all this data and all this information, but theirs is to like a huge scale. They're having to train, okay, I know that I train all these images. Okay, what's the difference between a stop sign and a person? Because if I hit a stop sign, that's not going to be as big of a deal as if I hit a person, right? Like if I hit a person, that's kind of a big deal. So you're kind of working with these weights and working with kind of trying to like optimize this to be able to classify everything with a lot of accuracy and a lot of precision. So, the more layers you add, the more, and you'll have like in businesses and stuff, they may have, layers that have thousands. They may have 1,000 layers, and each layer has 1,000 neurons. I mean, and so you've got a lot of numbers, you got a lot of crazy things happening, but you can be super, super specific, and you can model really, really complex situations and really, really complex, things to be able to say, okay, how do I classify all these different things? And so neural networks can be used to do a lot of really, really cool things. They're being used in a lot of industries. They're being used in the medical field. They're used in oil and gas. I mean, they're used in technology. Apple and Facebook, they all have neural networks. They all use this kind of stuff. And so, so it's a really cool thing, and it's actually pretty simple at its heart if you know a little bit of calculus. But I won't, get into all that nerdy math stuff. But yeah, it's really cool, and it's really interesting, and it has a lot of potential. So.
You guys have any questions? Anybody want to ask anything? Yes, Nadia? Okay, we had a question said from one of the students. Can y'all hear me? Because the mic is.
Yeah.
Okay. The question was, how has data science benefited you in your personal life? Yeah, personal life.
I can definitely answer. Oh, I don't know. Sorry, Chad. You can go ahead.
I was just gonna say, like, two things that I really like is kind of what Ethan said about, like, I think since data science can be used in a lot of different ways, you can do a lot of this stuff just on your computer at home. And so, like, I like sports. So, like, one thing that I, kind of want to get into is like doing sports analytics and like that kind of thing to kind of like predict sports games and that kind of thing. The other thing is also the stock market to use it to do that. But so I think it's interesting, and it just teaches you just think differently about the world, I think afterwards. But sorry, Marina, go ahead.
Oh, no, I mean, you really kind of hit the nail on the head with learning how to kind of change the world in a beneficial way. My domain focuses in sustainability. And so it's really allowed me to kind of figure out ways to like help our society, help our community, help the world in general, and apply it to different research. And so personally, I really love, my pursuit of grad school and my pursuit for certain research, and data science has kind of provided me an outlet in order to kind of apply those passions. I've being a part of Scholars Academy, UHD's data science program, I've done about 2 different in-house research projects, and then also I'll be starting at Berkeley in this following spring. And so when it comes to kind of benefiting your personal life, you really have this kind of fine-tuned funnel vision of really what you're passionate about and a way to expand that and learn how that helps the world, as cheesy as that sounds.
Can I ask about like, I guess I'm assuming not everybody who majors in data science is also in Scholars Academy, right?
Correct.
Is that correct? Okay, so is Scholars Academy something that, number one, is available for seniors who are going to enroll in college? Or is that something that they could join later on, or do they have to do that in the beginning, like once they apply to UHD?
They can do both. They accept high school seniors that are going in, or they will accept transfer students that are probably maybe going to HCC, transferring as well. So there are 2 different levels that you can enter from, and they both come to the same program.
Yeah, you can join any semester you want. So like I went to Lone Star, and then so I've only been at UHD for 2.5 years, and so my first semester I joined, and so that was it's you can do any of that anytime you want.
Also, if you have friends that would benefit from a program like this, and it accepts STEM majors, not data scientists only, so you can be a biology major and whatever science that you like and be able to join this group.
Okay. And what are I guess the kind of like base requirements for getting into I guess separately for data science if you wanted to major in that? Or is Scholars Academy also available for other majors, and what are the base requirements for doing that?
Yeah, Scholars Academy is open up for anybody who's trying to go into STEM. So like any STEM field majors you're able to go in. And some of the requirements is like a GPA of more than like 3.5, right?
For high school, it's 3. I actually have it right here. I can share.
Oh, for 3? It's 3? Okay.
3.
Yes. So I think you can see it now, right? Yeah. So for high school,
Oh, there you go.
Here. So if you're a high school student thinking about applying for Scholars Academy, you have a 3, and there's a minimum SAT score as well. And I think those are the two main requirements.
If we were to translate that, so a 3.0 is basically a B, right? Like a B average, right?
Yeah.
Because we're on a hybrid. We're on like a 6 or 7 point scale where like if they're in an AP math class, they could get 7 points if they get an A. But if they're on a on-level math class, they could get 6 if they get an A. So that sometimes gets confusing. So yeah, 3.0 is like a B, right?
Yeah.
So that's like if you have a B average across all your classes, and then the minimum SAT is 1,000.
Yes.
Okay.
And also every semester, I mean, I don't know if I think they said this, but you also get a scholarship, but you have requirements every semester as well. So like your first semester, you have to take the universe that like there's like a seminar credit where basically the director of the program, Dr. Parker, she goes over everything for the semester and like for like what it means to be in Scholars Academy and like that kind of thing. And so like there's like requirements of like you have to go on a field trip every year. You have to go on and they sponsor them, so you get to choose which one you want to. So like we visited, you know, like I think last semester I visited A&M has a nuclear engineering program, and then we get to see like their nuclear reactor and stuff. And you know, and then you have to go to seminars. You have like to always update your CV and your kind of like your resume and your personal statement. I mean, there's all different stuff like that you have to make sure you keep up with every semester in order to maintain membership.
Awesome. Does anybody else have any other questions, guys? You guys want to ask anything about Scholars Academy? I'll wait a few seconds for him to think about it. And I guess the last question is like you mentioned that you can get into Scholars Academy after you start, right? So if maybe what you did in high school, like you don't meet the minimum requirements, but once you have taken some classes at a HCC or a Lone Star and you're looking to transfer, then what you did in that scenario is what gets taken into account, not what you did in high school. Is that correct?
Yes.
Yes.
Okay.
I think most of us are transfer students. There's only 2 or 3 of us that are actually that came in as a freshman. Most of us applied in our after our first or second semester at UHD, and then we've been here ever since.
Awesome. Well, thank you guys for sharing that. I mean, we have about 3 minutes here, and I want to give you guys a chance to have a little break before we have the next class. I really appreciate you guys spending time with my students. I'm going to ask my students to go ahead and thank you guys. So they're getting ready to head out for their break. Hey, thank y'all. So yeah, so we really appreciate y'all spending some time with us today. And if they have any other questions as they think about it, I'll pass that along to Brian, and we'll see you guys, I guess, again in a few minutes.
Sounds good. Sounds good. Thank you.
Thank you, guys.
Thank you, guys.
Y'all want to wave hi?
Oh, we should go ahead.
There you go. Y'all see him? One of them just showed up late. Needs to go get a tardy pass. I'm gonna allow it because it's Thanksgiving, though. And for my students who are virtual, these, as I mentioned earlier in the week, all the students here, we've got some undergraduate and graduate students from the University of Houston downtown from the data science program. So I'm going to turn it over to Brian to go ahead and get it started. So thank you guys for being here.
Fix my screen share. Okay. So welcome today, students of Springwoods High School. We are, give me a second.
I think we should do an introduction about ourselves, right? Or
Yeah.
should we just, okay.
Yeah, I
So-
think we do the introduction instead.
Yeah, okay. So my name is Marcus Arzanon. I'm a second year in UHD and I'm studying data science right now. And I'm having a pretty good time. Having a pretty good time learning about data science, yeah. I'll go ahead and pass the mic.
Hi, my name is Chinacheram Eze. I'm originally Nigerian. I moved to Houston like 5 years ago, and I'm an undergraduate student studying data science with a double minor in stats and mathematics. So I'm pretty excited to be talking with y'all today, because I remember when I was in that grade level, and it was really
My name is Chad Weatherly. I'm really from Montgomery, kind of like the Conroe area, if you've ever been north of the Woodlands. I am also a senior at the University of Houston downtown, and I am studying data science with plans to hopefully go to graduate school afterwards. So hopefully do like a doctoral program in some kind of computational engineering or math or something. So yeah.
Hello, guys. My name is Marina. I am a senior graduating this December 2020 from the data science program. My domain focus is in sustainability. So that means you'll learn about a little bit more of that later, but I basically study data science in the sustainability program. And yeah, I'm from Sugar Land area. I originally went to UH, the main campus, and then I transferred to University of Houston downtown for the data science program. So excited to be here.
Hey everyone, my name is Ethan Nguyen, and I'm a transfer student to UHD from PCC, which is Pasadena City College from LA. And I'm a senior. I'm currently a senior in data science major focused in domain focus of math and actuarial science. And I'm hopefully to get into the grad program in MSD at UH main campus.
So hello everyone, my name is Hui. I'm a senior student in University of Houston downtown as well, and with the domain focus in biology. My goal is that I want to go for a graduate school with biology computational, and hopefully that it would change the world problems. Thank you.
Oh, hi guys, I'm Anwes. I'm from Vietnam. Currently, I'm a senior student in USD, and I major in data science, and my domain focus in computer science. All right, thank you. Yeah.
Hello, guys. My name is Tan, and I'm a sophomore at the University of Houston downtown. So, as you know, as a sophomore, I studied a data science major, and I'm still applying and waiting for the opportunity to be the member in a research team at the campus, University USD campus. So, thank you for joining.
My name's Asfar. I'm also a sophomore student here at UHD. I don't have any big project I'm really working on right now. I did some stuff over the summer, but right now I'm just looking forward to Thanksgiving break, I think.
Us too.
My name is Brian, and I am also a senior at UHD. I'm graduating in the spring semester. I'm graduating in May, and I'm looking forward to possibly going into graduate school and looking at artificial intelligence programs and studying more about that after I graduate with my degree here at UHD.
My name is Dr. Tim Radel. I am a professor of mathematics in the Department of Math and Statistics at UHD, of which data science is one of the degrees that we offer. I've been at UHD since the fall of 2005, so quite a while. I do teach mostly mathematics courses, but I also occasionally teach some statistics courses, including one this semester, decision mathematics, which a number of the students you just met who are data science majors are taking. That's one of the courses in statistics that's required for data science. I've also been a mentor for Scholars Academy for a few years now. And so most of the students in my mentor group are data science majors. Within the Department of Math and Statistics, we also have majors in mathematics and also in applied statistics. Very happy to be a part of the data science program, even though I didn't major in data science. It's nice to teach courses that are required by the program and to meet such great students as the ones you're meeting today.
I guess I'll go next. I'm Elda Piedad. I'm originally from Angola. I'm majoring in data science with minors in mathematics and statistics. And my plans for the future are, I've been accepted to a TechU program with Amazon. So I'll be working for a year towards certificates like cloud practitioner certificates. And in the future, I do want to go to graduate school, either master's or PhD, depending on where my mind is in the future. I really enjoy UHD and Scholars Academy. I hope you can find a program like this or join ours.
So I think that's everyone here. So I'm gonna move on with the presentation for today. And so again, we're all a part of Scholars Academy, and Scholars Academy is a scholarship and organization at UHD, and it's really there to help the students achieve more and get them to learn more about the opportunities that are there at the university. And so I think I'm going to ask Dr. Rado to talk more about Scholars Academy, because he is a mentor, and for the students, we will talk a lot more about it after if we have anything else to add.
Sure, yeah, I'd be happy to. So yeah, Scholars Academy, as Brian said, is it's an academically competitive program in the College of Sciences and Technology at UHD. And so students who are members of Scholars Academy are majoring in either mathematics, statistics, data science, any of the natural sciences like biology or chemistry, geology, physical sciences as well, or computer science or engineering technology. And so it is a competitive program. You need to maintain a certain GPA in order to remain in the program. You need to apply to become a member of Scholars Academy. But if you are accepted into the Academy, you do get scholarship every semester that can definitely help with tuition, books, things like that. So all of the Scholars Academy students are members of a mentor group, and you're meeting members of one group here, and I'm the faculty mentor for that group. And usually a mentor group has anywhere between 12 and 14 students or so. And during the course of the semester, we occasionally meet for networking meetings. Students are required to attend a certain number of seminars and field trips every semester as a means of learning about the different fields of STEM, not only the one that they are interested in, but other areas as well. Scholars Academy is an excellent networking organization, and that it helps students in applying for jobs after they graduate, or for after they graduate, or graduate schools as well. So it's an excellent organization. It's been around for many, many years, longer than I've been at UHD, but I've been happy to be a part of it. And we've had, the Scholars Academy has had great success in placing students or helping students get into graduate schools or jobs in industry. How's that, Brian?
Yeah, that's good. So I'm going to toss this to the rest of the mentees. How has SA benefited you? And so I'm going to try to answer this. For me, that's helped me a lot with writing personal statements and writing things that I wouldn't do without it. I wouldn't be able to have a CV or learn more about the opportunities such as research or internships that are being offered here or at a different university that they partnered with or they advertise. And so that's helped me a lot throughout the years of finding opportunities.
For me, one of the major benefits, since I'm an international student, I didn't know about the system here in USA, so I was able to learn that I'm supposed to pursue internships, opportunities, attend career fairs. So I was guided, because before I really didn't know what I was doing. I was just going to classes, and I thought the point was to go to the classes and pass them. But no, the point is to network, build knowledge, explore, and participate in competitive programs so that you can actually grow as a professional and as a person, not just as a student. The other benefit for being an international student is that I got an international student waiver. It kind of comes automatically with receiving a scholarship. Many people don't know that, but it's kind of nice if you have friends that need that information, share with them, I guess.
For me, I would say one way Scholars Academy has definitely benefited me is it's helped me to be more confident in myself, because a lot of times when you are in your career or trying to find a job, you have to know how to sell yourself, how to talk about yourself. And a lot of times you don't know that straight out of high school. So being able to attend like career fairs and graduate fairs has given me the confidence to be able to know what to say, how to approach graduate schools, how to approach employers. And also, Scholars Academy was the first, once I joined in my freshman year, straight out of high school, that was the first time that I realized that I'm not supposed to have a table in my resume. So it was kind of like, it helped me a lot because they helped me. I never knew what the difference between a CV and a resume. And it was in Scholars Academy that actually opened my eyes to say, okay, you need a resume, you need a CV. And I feel like if I did not meet that opportunity of being part of this program, I probably would have gone to my senior year without a resume or a CV, which is detrimental to your career because you need a resume and a CV to apply to jobs. So definitely it's helped me build that self-esteem, and I'm able to boldly go up to an employer and tell them about my skills and really score an interview. So that's something that you don't really learn in college except you find an organization like Scholars Academy.
On my view, to joining the Scholar Academy, I receive a lot of benefit. Like, every week I receive the email from the staff that's sending about the information of the field trip and cinema to join, and that's every week to have a lot of event to join, and you learn a lot from them. Also, they sharing the opportunity. Experiences we can learn from them. Also, another benefit for the Scholar Academy is you can receive the help directly from the staff and faculty mentor. Like they will help you work on the personal statement, CV to write better. Also, you receive from the interview. Introduction of the internship and research for such you prepare for the joining their team and prepare for the future.
I think that covers a lot about SA and what it does for everyone. I think you'll learn a lot more as we go through these questions and we talk about data science. Well, I believe that the first question that we have is kind of a broad question. What is the background of a data scientist? So yes, a question that goes along with this is, what is a data scientist?
Well, like even maybe a little even simpler, it's like, what exactly is data science, especially if you're like I can tell you, before I got to UHD, I had no idea what data science was. I mean, that was only like 3 years ago. And basically data science, it's a very ambiguous, it's a very broad area. It's a broad field, but basically you're combining math and statistics and computer science. And like I told the last class this, but for me, I always see it as like you're trying to find patterns. So you're basically given or you have like just a big set of data. So a big set of information that you're trying to find patterns, or you're trying to, kind of uncover information that maybe you don't see just by looking at it. And basically it's kind of become an important and a big thing, because in the past probably decade or so, maybe longer than that, companies have started to take a lot more data just in general. That's why you see all this, there's a lot of stuff going on with social media companies and big tech companies about all the data they're gathering. And so it's most companies are gathering lots of data. And so, it's kind of like, what exactly, or what are we supposed to be doing with this data? Like, what's the point of it? Like, what are we going to do with it? And so we basically use, math and statistics and that kind of stuff to be able to really analyze it, precisely and analytically. And when we use computers to do that, which is why you need the computer science portion of that.
I guess I could go a little bit into, the detail of what our program specifically, creates a portfolio or background of data science for the students. And so through our curriculum and so forth, we kind of learn this pipeline within data science. It's like first you understand how to wrangle the data, like how we collect data, how we're going to kind of compile it all together in a way that's formatable. And then we go into this step of like cleaning and pre-processing the data, both with like wrangling and pre-processing. You're really using a lot of computer science tools. And so then after you prep this data and you're ready to kind of understand it and explore it, then you go into modeling. And modeling is where you use a lot of your math and statistics. And so after the modeling, hopefully you get an understandable, usable model and you're getting results that you expected, or perhaps results you didn't expect that kind of open new doors and windows. And so then you go into validating that story and really trying to explore and tell that to people that perhaps don't know data science, but you want to show them your results. And so I guess that's why the curriculum is a part of our program, really comprehensive and difficult at some parts, because it really revalidates that background that data scientists need.
So, as a data scientist here, we know that we learn about a lot of data collecting, data wrangling, and building models. But when it goes out to the workforce or the working in the field, what does it take to become a good data scientist? What kind of things should they know? What should they learn?
I want to start with answering that question. I believe to be a good data scientist, you have to be a constant and maybe a forever learner. You have to be updating your skills every day, reading literature papers, understanding what other people are using in technology, consistently apply what you learn, because there's so many things to learn that if you don't apply constantly, you kind of forget. So it's not like riding a bicycle, because you never forget to ride a bicycle, but you kind of forget to do data science if you don't do it. So it's the opposite. So just be an explorer and learn continuously, be curious. Yeah.
Yeah, I think that's spot on, Elda. I'll even add on to that. I think another good thing to be a data scientist is to be able to critically think, because a lot of times the problems that you're given are not things that you know, is not that you have a specific, you may not know exactly what the end goal is. And so you've got to be able to critically think and say, okay, you know, what are the things that I, excuse me, what are the things that, like, you know, I know these different tools, and, oh, I know this from statistics and this from math. And like, okay, maybe how could I use these on this? Or, and so, you know, being able to critically think and being able to take all your information and kind of make good decisions and problem solve, I think is very important as well.
So let me add it on that.
Oh yeah, sure. Go ahead.
Sorry. Okay, sorry. So I think the good point to become a good data scientist is to have the good communication skill, because you need to identify what exactly the goal that you are solving. And sometimes data scientists, they work by themselves, or maybe they work with a big team. So we have to communicate like effectively with others in order to check the process of coding, and if you miss something, and your co-workers can help you with that too. So that's one more point.
Yeah, I think I'll add on to that one. So I think a good data scientist should follow, you know, the data science code of conduct. You definitely need to understand the terminology, and then along the way, that communication with your client, you have to understand that the client request had to, you know, like follow the laws. That's the first thing. And second thing, that is not gonna at first, you know, like other clients, you know, interest. So always question yourself that when a client give you the data, what is the purpose of analyzing them? And then when you discover the meaning, you definitely need to communicate the, you know, both of the pros and cons to the client, and, you know, like make sure what you are trying to do. So when you know, like produce into a product, it does not cause any harmful to any other people. So I think that's how to become a good data scientist.
Before we move on, this is important for, since you guys are computer scientists, maybe thinking about transitioning to data scientists. So I have a mentor, right, from Microsoft, and she's a data scientist. She majored in computer science, but she interviewed for a software engineering position, and then she said, well, I I'm interested in data science. So they were able to put her, even though she had a computer science degree, they were like, okay, you can apply this computer science knowledge into data science. And she says, a good data scientist will know how to create a program, write good code, test, and validate. A good data scientist will be good at modeling, data manipulation, cleaning, normalization, visualization tasks, and so on. So you have to be, if you want to go into, because data science is kind of, it has like a spectrum where it's data analysis in one end. You don't need a lot of compute, like a lot of code experience. Maybe you can go ahead and work with Excel, but then at the end of that spectrum, maybe you're going to be a machine learning engineer. So that way you are a computer scientist, even though you are a data scientist. It's like a overlap of words, but it's actually the same thing. Yeah, so I just wanted to put that out there.
Okay, I think that covers it really well and what data science is. There's a lot of things you can do, and there's a large end of kind of like a beginning and then kind of a higher endpoint where you have the machine learners and what they do as building models. So as I guess is going everyone, why did you become a data scientist major, and what part of it really interests you? I think I can answer this. For me, I think it's the adaptability. You can go to anywhere, any field you want. If you want to work in a tech company, you can work for Google, Facebook, anything like that. You can go ahead and do that. But you can also go into a biofield or a biology, and you can do research there. You can build machines and build models to do research such as cancer cures, or building a vaccine for maybe COVID or something like that. So the data scientist can do a lot of things in different jobs.
For me, what interested me in majoring in data science straight out of high school is that I didn't really have like, my heart wasn't like set on a certain path coming out of high school. Like I know a lot of people that like, I want this job and I'm going to do this and do this, but I really didn't have like my heart set on anything. And data science is this field that combines like two things I was really interested in, which is computer science and math. And I know math isn't like everyone's like favorite thing, but I was like, okay at math, and I can do a little bit of math, but it encompasses both computer science and some math. So I think it's good for people that maybe aren't like, don't totally want to go one way into math or all the way into computer science.
So I guess another question is, why do you enjoy data science? And
I would say for me, just like everybody else said, I like the flexibility. I kind of see data scientists as people who predict the future. And I know, like for me, on my free time, what I like to do is modeling. So I'm just like, I need a field where I can enjoy doing what I'm doing, but at the same time apply my skills that I learned at school. Because there's this article that said a lot of students who graduate from college don't end up working in the field that they actually studied in. So I was doing my research, and I saw like with data science, I can work in a place like Nike or like some fashion industry and kind of predict how many customers they're going to get in the next, I don't know, 30 days, or how should I make their products to be different to attract more customers. So I was like, that sounds like something I'll be interested in. I can still be in the fashion industry and still be applying my skills that I learned straight from college. So that's one part that I enjoy, like the flexibility. You can really do anything, like work in any field at all. And I don't think there's any other degree that is as cool as that. That's my opinion.
Something that I enjoy about data science is like, while you're working, you're also learning. So like if you're like, whenever you're doing data science and you're just like sifting through all the data sets and all the information that you're handling, you also learn a lot of new things that you probably would have never asked yourself inside that field. Like I could be like, okay, so what's like the most searched thing on Google, or like, oh, what's the most highly rated like restaurant here that's kind of like, I don't know, underground or something. Like I thought that was like pretty interesting, like how you could learn while working and all that. You never have like the same experience whenever you're doing data science.
Let's see. Is data science hard to learn? I think that Marcus actually kind of covered something like that. He just answered it, where you learn as you go through, as you do it. So it's not really hard to learn, but the harder thing is to adapt and keep learning about it. And you always are discovering new things, new programs and new coding languages, and you want to work with them instead of working with, let's say Python. You want to work with R, a statistical programming language that most colleges use for stats. If you want to do if you take math courses, you'll probably do something in R, or maybe you do something in a new programming language such as Julia, and something built for machine learning. And so it's kind of a two-way thing where you learn, but you keep learning and you don't stop learning.
And to add kind of onto that, it's hard in the sense that you have to really synthesize computer science, statistics, and mathematics. There's points where you're studying linear algebra and you're like, well, what does this have anything to do with data science? And then later upon your degree, you discover, oh, that's really important for whenever the neural network is going to then reduce the bias, or, you know, how computers work with sparse matrices and all these really complex topics. It starts to kind of join together. And so despite the fact that it's hard, it's incredibly satisfying. And I guess this goes back to like, what do you like about it? But when you're coding and having to go through this really intense project and the data set's not working with you, it is incredibly satisfying to get it to work, or to get your model to train as if in the way that you wanted. So it's hard, but it has tremendous benefits. And I do want to highlight that.
So we do have roughly 20 minutes left here, but I do want to cover one last question before we get into something very cool, hopefully, that someone's got to code up for the computer. We're going to do something with computer vision, hopefully. But last question is, like, these are CS2 kids, I believe. And so we kind of covered it throughout the session here, but what's one major benefit over computer science?
I want to say something about this. So I used to think that data science and computer science are totally distinct, but as I was searching through the graduate schools and the computer science programs, I saw that actually, for example, if you go to MIT, they go ahead and they say focus in machine learning, focus in NLP, natural language processing, focus in machine learning for sustainability. So all of those topics under the computer science umbrella, they were actually the data science that we are learning at school. So I was like, okay, so I guess data science is computer science. It just depends what you're doing with that computer science, because you could be building software and apps. Data scientists don't do that. Data scientists basically work on the computer science in analytical way, you know, the maybe Netflix shows that pop up inside the app, that's computer science, but it's data science. It kind of overlaps. So I think it's important not to like think just of the word data science, but think of the work that a data scientist does. And you can pick whatever title you want. Okay, you can be a computer scientist that does computer science. It's just the work. Just pay attention to that. Yeah.
I was going to say for that question, I think for me, like a data scientist is able to take the tools that a computer scientist builds and like make it make sense to human beings. So that's like the best way I can explain it. Like I can say, like, for example, a computer scientist, like Elder was saying, you build an app, and most people don't understand coding. Most people can't look through a chunk of code and say, okay, this is what is going on. But data scientists, they understand the coding part and they also understand like the analytics part. So they're able to analyze that piece of code and also the data set and make and interpret it into a form like a report to show to like their boss or whoever and say, okay, based on what the computer scientists did and also the data that I analyzed, this is the results that we're able to get. So it's kind of like they're not data scientists are not computer scientists, but they understand the skills and the tools that are needed for computer science, and it makes it a lot easier to interpret it to you know, a layman term.
I think we covered a lot about data science today, but one thing before everyone goes, I kind of want to like do a demonstration of what a data scientist can do and what they do for research and for coding. So I think you can screen share, but there's a little computer vision that Anne was working on his own, and I want to see if he can pull it up and share to everyone.
Oh yes, let me share my work I have done so far. Okay, let me. So have you seen my my screen?
Yes.
Yeah, we see it.
Okay, yes. Okay. All right. So I built this model from YOLO's algorithm. So I have to and okay. All right. I have two classes. One class is person, so you see my face right now, right? And another class is the cell phone. So, oh, yeah, remote cell phone, yeah.
Oh,
yeah, some
drive.
yeah, sometimes it's the yeah, and in the pants. Oh, it doesn't work. Oh yeah, that's so far. Yes, my goal my goal that's I want to try something like that to yeah. Okay. Yeah, that is my answer.
Okay, that is actually really cool.
Yeah.
So I think that we have a couple minutes left, and I kind of I have this thing that I sent to Mr. Angel for everyone to check out, but it was a kind of a neural network playground. So if you guys, I'm pretty sure you guys don't know, but neural networks is kind of the basis of machine learning, and machine learning is one of the top things that a data scientist works with. And so in a neural network, it deals with a lot of calculus and a lot of derivatives, but I won't go through that with you guys today. But building a neural network is like working with a human brain, where we have neurons that work and activate, and it tells us to do something, like raises your hand or to type something or write something. So this works in the same way, where each layer kind of is like a different thing where it tells something to a different neuron. So maybe your brain tells a specific area of your body to move it, and that movement interacts with another movement within your body. And so it goes through all these different layers to produce an output. So let me see what. So at the beginning, we have a set of features or data that we put through the system. And so if you want to do machine learning, we would add several layers, and each layer tells a different certain thing about the data. So as we can see here, this little neuron right here tells us these little 4 sections, and this one tells us about that section. So if we add more layers, we can tell much more about different little sections about the data. And so after some time, each one of these weights or connection points between each neuron is adjusted. So let's say, for instance, this part right here is yellow, but it's showing up as blue. And so what's going to happen is this neuron is going to be minimized in its impact on the model. And so it's not going to have as much input into the model as it would before. And so part of what machine learning is training models. And so you can go ahead and have things such as, and we can have the model trained, and we can see that over time, training the model 60 times gives us this output, which was at the beginning, nothing. And if we take it slowly, we can see that over time, the model can slightly tell what is what and what kind of data that we're working with. But over time, it improves it and it produces an output that we can successfully classify what is orange and what is blue. And we can, part of the playground allows you to work with the learning rate. How fast does the model train? How fast does it get to that point where it can classify the data? So I was working with 0.1, but let's say I was working with 0.3 this time, the model is somewhat instant. It does it right away. What it was before, I believe it was 60, and now it's like 10 or 15. And so it can successfully classify the model right here. So I wasn't sure if anyone else wanted to sort of cover this a bit more.
I'll add on to it. Can I share my screen again?
Yeah.
Okay, you guys can all see that?
Yes.
Yep.
Okay, so basically a neural network, what it does, it's basically just like a function. So whenever you're, if you're, because you guys are all in high school. So, if you think about like algebra or geometry, but really algebra, right? You're basically dealing with different functions. And so what a neural network does is, like I said, like Brian said, it's neural because it's basically based off of, it functions very similar to the way that your brain neurons function. And so, in your brain, if you have one neuron that fires, it'll send that, whenever that fires, it sends, it'll send that signal to another, to other neurons, and then those will fire, and then those will make other neurons fire, and so on and so on. And so in a neural network, it basically is doing a very, very similar thing. It's very, very simple. Basically, we put in data. So like, let's say, one of the examples that this website uses, and this website is just used to kind of showcase, not necessarily every specific detail, but just kind of show you kind of how it works and give you an idea, right? So we're trying to, as you can see right here, we're trying to classify, right? So let's say I get a bunch of data, and let's say this is my data right here, and I'm trying to figure out, let's say that the orange ones, if I get in, I'll go into the street and I just am interviewing people, and I take values of what are their height, their weight, what are their levels of testosterone, levels of estrogen. I'm trying to classify, if they are male or female, right? And that's something that I'm trying to classify just based on getting that other information. Well, I know, okay, if I take 100 samples, I'm going to use half of those samples to train this function. All this function is I'll put in information like height, weight, all that information in here. And all it does is a neural network just multiplies all of those numbers that I put in times smaller numbers, and then it normalizes them, which basically means it just makes them smaller. And it does that over and over and over. And so each neuron in each each of these little points is called a neuron. And each of these neurons, it is multiplied by a number and it is sent to one of these. So it's like, okay, when this one fires, okay, then it makes this one fire, which then maybe makes this one fire, and it goes on and on until it classifies. And then each epoch or each iteration, the way that we train it is that after each generation, we test out a point. And if it classifies it correctly, then we don't update it all. But if it classifies it incorrectly, then we will update all of these weights, basically using calculus. It's using derivatives. And so these things are important because, and you're like, okay, well, how does that really work? Like, if you look at it, you're like, that doesn't really make any sense. But like, you know, if I look at, you know, let's say even this one right here, I only even have, you know, even if you were to look at it, if I just gave in one value, so it's like I'm just giving in the X value right here, right? So if I train this, it's going to train it pretty much down the middle, right? And you're like, oh, that kind of makes sense. So what this means is that, okay, if I plug in a point, if I plug in a random point right here to this neural network, you know, it's going to classify it as orange. If I plug one in right here, it's going to classify it as blue. Anything on the line, it may be kind of weird, you know, maybe not exactly, but you know, you can see it pretty much classifies the data points that I have pretty well. Okay. Well, even if I just had, you know, another function, so let's say this one's height, this one's weight, and I just have weight. Okay, well, it's going to classify it down the middle again. And you can say, okay, well, that, you know, it classifies it pretty well, but, you know, I'm still getting points like this one right here. That one's not classified correctly. It would classify it as orange, even though it's really a blue one. It's like, okay. So as you can see, the more complex you get, the more features you put in, it gets more, it's able to get a lot more specific and a lot more precise. Which can be helpful. So, you know, this data set, it's pretty easy to classify. It's pretty easy to see that all these data points are right here and all these are right here. But what if we have something crazy like this, right? How do we do that? Well, as we add more data points to each of our things, and let's say even we have, we probably only need like 3 hidden layers. But let's say, you know, we did that, and we run this. Well, you can, when you look at it, you're like, okay, it kind of starts off weird, but you can see it kind of starts to classify it over. And mind you, this is running, so it's at each iteration, but it's running, and right, you know, we're classifying things mostly well. We'd like it to be a little bit smaller, and it's getting there. But you know, right now, if I stop it right now, you know, it's classifying these orange ones. It would classify those as blue. We don't want that, and so it's good, but it's not perfect. So you run that, and you train that. And it's like, okay, well, that's great, but like, what is this actually used for? And the example I gave to the last class is like in Netflix. So I assume that just about every single person in high school and in the world watches Netflix. There's a lot of people that watch it, right? And so whenever you watch Netflix, what they do is they look at, okay, so if if I'm watching Netflix and my favorite show is The Office. So when I watch The Office, they're telling me like, okay, you know, if I watch The Office enough, I rewatch it, and I hit that I like it. Well, then Netflix is going to put that information here, and they're going to do that for all the hundreds of millions of subscribers they have. So they have a good idea of what people that like The Office, other shows they like. So guess what? It's going to probably recommend to me, okay, hey, you may like Parks and Rec, you may like things like that, which is why, you know, if you have like depending on what shows you watch, you get different recommendations. So like on my recommendations, I get a lot of like action shows, and I get a lot of like historical dramas and stuff like that, because that's the kind of stuff that I like. And movies like that. And whereas, you know, maybe I have a friend that watches a lot of horror movies. Well, they're going to get like, you know, American Horror Story, and they're going to get Stranger Things. They're going to get things that are a little scary, and they're going to get way more like that. You know, and then my sister likes Grey's Anatomy and stuff and shows like that. So she gets all different kinds of recommendations that I don't. And so neural networks, they can be used to do all different kinds of things. So and the other example I gave was they can be used in the medical field. They can be used in like oil and gas and engineering, in finance, and like even in like self-driving cars. So like if you're trying to classify, okay, I have an image, and like you just saw On's his demo. Basically, he created something that recognized, okay, this is a face, okay, this is a phone. You know, but and when you have self-driving cars, it's kind of important to know, you know, sometimes what the difference between a stop sign and a person is, right? Because if you hit a stop sign, that's, you know, that sucks, and you got to maybe pay for that, but it's not that big of a deal. But if you hit a person, well, that's a big deal, and it's in the news, and you're in a lot of trouble, and your stock price drops, right? Like that's a big deal. And so, you know, you may have, and all big companies do this kind of stuff. So, you know, you may have functions that have thousands of features, so thousands of inputs, and they also have thousands of hidden layers, and each of those layers has 1,000 or more neurons. I mean, they're huge, and they're they can be very, very specific. They can be very, very complex, but they can be really, really precise, and they can handle these complex problems and classify them well, and classify them pretty easily. And it doesn't really take a lot of work on our end. We just got to let it run. We just got to let it keep going. And the longer we let it run, and the more powerful our computers are, right, then we're able to kind of like, then we're able to get it better and more accurate. And so this is kind of like one of the biggest tools right now that's really popular, that's being used in data science, and that we use, like, that we learn about in our classes. And so this is something that's kind of interesting, and it's something that, especially as computer scientists, like, you guys can start using this now. I mean, even this website, you can go on this is a free website, and they have actually, it's based off of a package called TensorFlow, which you can use now. I mean, you can do these kinds of things to start to do this. And so it's a pretty cool time to be a data scientist. And this is a pretty cool, example of how this kind of stuff works. So.
Thank you, Chad. So I believe it's almost time for them to go, but one little last research. So if you guys are interested in UHD and our little programs for Scholars Academy about biology, computer science, or data science, for freshmen, they can apply, and all they would need is a 3.0. I believe that Springwoods is using scaled, so you guys would have to convert that. Minimum SAT of 1,000, and that's usually, those are two major requirements, but you guys also would have to do little writing statements of what your goals are, your transcripts, and that's it. And you guys would apply into this program, and you guys would be accepted. So if you are a transferring student, you guys want to go to another school, a community college beforehand, you guys can apply once you go into UHD. Sort of the same applications apply, but no SAT score, GPA requirements are still there. So that's really.
And I think that one's important too. Thank you for going over that, because I have some seniors in this class, and maybe they don't have those requirements now, but and some of you mentioned in the last period, some of you transferred from community college into this data science program. And so I think that's really important that these kids here in my computer science 2 class hear that as well, so that they know what their options are. And the bell is going to ring very shortly. So I just want to say thank you guys for taking the time and spending it with us. I think they had a lot of interesting information. I'm going to ask them if they have any other questions as a follow-up. And Brian, I'll send those to you. Okay, so that way, if you can get those answered, that would be great. It'd be great. So thank you guys very much. I hear the announcements coming on now, so they're about to kick us out. Thank you, guys.
Thank you for having us.
All right.
Please remember when you're at lunch and